you are today. And welcome to the webinar, Harnessing the Power of the Cloud for Grid Computing. We'll start the webinar today with a couple of polls to find out more about our audience. So we'll put those up on the screen if you could take a moment to fill them out. Here's the first poll. What is your current grid processing situation? Take a couple moments to fill that out, please. Looks like we've got the answers here. And it looks like the majority of you want to take advantage of cloud resources when you need them. So it looks like you're looking for flexibility. And that some of you maybe are just doing some research as well as having an upcoming project that you're going to work on. So let's go to the second poll. Thanks for filling out that first one. It looks like it'll pop up here in a second. Here we go, the second poll. What types of grid applications are you currently running? And on this one you can select more than one of these, so go ahead and choose which one best fits your situation. Scientific research, financial reporting, media transcoding or processing, general batch processing, or another type of application. Take a moment to give you time to answer that. And here are our results. And it looks like the majority of those attending today are doing general batch processing with a good amount doing scientific research. So that definitely fits what we see in our customer base too with our grid application, our grid processing solution. And now we've got one last poll to give us a little bit more information about how you're using the cloud today. And with this question, we're trying to find out specifically how you're using the cloud in the infrastructure as a service model. So examples are Amazon or Rackspace. If you could take a minute to answer that one. Looks like the answers are coming in, and here are the results. And oh, this is great. There's a pretty even split here among the audience in terms of what you're doing with the cloud. So I think this will be a really interesting webinar for all of you based on that. And that's our last poll. Thank you for answering those. And now we'll get started. My name is Elise Arthurs, and I'm the Director of Partner Marketing here at RightScale. And before I introduce our speakers, I just want to remind you of a couple housekeeping items. We'll do a question and answer at the end of the webinar. So during the course of the entire webinar, you can submit your questions. And you do that using the question tab on the GoToWebinar panel that you see on your screen. And you can just submit them anytime, and we'll either answer them right there. We've got people on the Q&A line, or we'll save them till the end and we can answer them live. So go ahead and shoot us all your questions. And now I'd like to introduce our speakers. And it looks like we're going to the next screen. We've got Michael Crandall, who will kick us off. He's our CEO here at RightScale. And then Josh Fraser, our Business Development Vice President. And Dave Welch, who will work with him on showing the demos, and he's our sales engineer. And on the Q&A line, we've got Matthew Small answering your questions. So remember to submit those questions anytime. And with that, I'd like to have Michael Crandall now start the webinar.
Thanks, Elise. Well, I'm really excited about this webinar today. I think it's going to be fantastic because of really the new power that's enabled in ways of deploying grid applications in cloud architectures, and made very easy and delivered that way by RightScale. So I'm excited. You can see here on the agenda that we'll be reviewing, kind of giving an entire overview from an introduction to RightScale to what customers are actually using the system for, some common challenges and how we overcome those, and then a couple of live demos diving into the details of actual grid deployments running in the cloud right now as we speak. So those are always kind of gritty and fun to see. And then a review of benefits, and as Elise, as you mentioned, we can accommodate Q&A all the way through, so please do send your questions in. So to launch in directly, for those of you who maybe are not familiar with RightScale, very briefly, RightScale is a cloud management platform. That means that we help companies manage their IT in the cloud, and we've accumulated over 20,000 users of the system. We've launched well over 1 million servers in the cloud and powered really some of the biggest scaling events that have occurred in the cloud since its inception. You see some listed here on the slide, as well as running some of the largest static production deployments in the cloud to date. That means not just scaling up and down, but steady state running of servers. So all this adds up to the fact that we have a lot of experience at RightScale focused specifically on cloud computing and running workloads in that environment. Here's where we fit into the larger picture. So RightScale, as a cloud management platform, lives on top of infrastructure as a service cloud providers. These include everything from Amazon EC2 to Rackspace, as well as so-called private clouds, Eucalyptus, Cloud.com, vCloud, etc. And what we're about is the big problem that we solve essentially is allowing companies to get quick access to cloud infrastructure, namely fast provisioning, pay-as-you-go for dynamic workloads, all around enabling agile delivery of applications. So at the end of the day, this lets you, in whatever aspect of IT that you're dealing with, be more agile in delivering application to business users. We offer an environment that really covers the whole life cycle of delivering cloud-based IT resources. And RightScale itself is a software as a service platform, namely a web-based system that really provides a portal into all of your data center resources, regardless of where they are, whether they're in a single public cloud, across public clouds and regions, or split between private and public clouds in so-called hybrid clouds. Now, what we're going to be diving into today is grid computing running under RightScale. So we're specifically going to dive into our grid solution pack. And one thing I'd like to point out as an overview here is that we have customers ranging from enterprise to Web 2.0 to startups, small and medium business, and everything in between. Cloud is a very broad, horizontal, disruptive force in IT, and as such, it's become appealing for companies of all sizes to leverage. So we power cloud grid applications from companies ranging from enterprises like Eli Lilly, it's a biopharma company, to Web 2.0 companies like Sling Media with their Sling box providing entertainment content across a number of different devices. And when we drill into grid here, I also wanted to point out there are different definitions or maybe associations that we have about grid computing. The kind of grid that we address today in our solution pack is computing where many independent computations can be distributed across a whole network of independent computers. So this is more of a distributed grid where you can break jobs down into discrete components and process them independently and fire up whatever number of servers are required to take care of that. What's coming in the future is a grid that's more focused on processing large or complex computations that are designed to run on a tightly coupled cluster of parallel processing or a supercomputer kind of approach. It's really HPC, high-performance computing. That's something that we expect to have an answer for actually in short order. It's not something we're shipping today, but we'll be letting you know about that if you're on our mailing list. We expect to do a webinar on that in the future, and if you have a special interest in that, please feel free to reach out to us and ask. With that, I'd like to hand things over to Josh Frazier, our VP of Sales and Biz Dev, who will take us into the details about Grid. Josh?
Thanks, Michael, and welcome, everyone. So let's start off and talk about a few of the challenges and what we've heard from our customers that are taking advantage of this solution. You're probably all familiar with some of these, but let's dive into some of the key themes here. We see a lot of challenges both for IT administrators as well as end users. Really starting with this grid environment internally that is fixed. Fixed both in terms of size as well as fixed both in terms of what the underlying machine characteristics are. So that leads to a whole host of issues. Often you have spotty utilization, as noted on this graph, where a job may run and max out based on your overall grid size, and then all of a sudden you process what you have in the queue and you're getting very, very low utilization rates. Another big issue is because of this fixed grid environment, there's also a lot of heavy lifting that IT admins have to go through when it comes to architecting the specific app or workload to map into that fixed environment. And then last, but of course not least, is cost. This grid that you set up internally is dealing with a fixed sunk cost, and then often on top of that, you may be running a grid engine where additional licensing costs would factor into that. For users, what this means is you're waiting for resources. This notion of a job dying in the queue is a very real phenomenon. Also, if you're looking to run an application or a workload that requires resources beyond the capabilities of the underlying machinery that you have on your internal grid, or simply expands beyond the overall size of that internal grid, that's going to result in either a job that can't run or can't run effectively or can't run in the required amount of time. So very, very real issues dealing with an internal grid environment. Want to now focus a little bit, Michael alluded to this, but specifically what we've seen so far as far as customers taking advantage of RightScale's grid solutions in the cloud. This is certainly not all-encompassing, but these are the four main categories that we're seeing adopt thus far. Pharmaceutical companies, so here you have many, many different types of jobs, some using public data sets and others using proprietary data sets, where they need access to hundreds and hundreds of servers to run jobs in a very specified period of time. So a lot of activity in the biopharma space. Insurance claims, companies that deal with things like fraud detection. So a customer of ours is running workloads against helping HMOs and PPOs spot fraudulent claims. So there you have data sets where they're running algorithms against the specific claims to spot abnormalities. Grid is actually heavily used in Web 2.0. This category often isn't really thought about, but in fact it is quite a common use case that we see, and we see this even more so combined with other types of scaling type environments within RightScale. Animoto is a customer many of you have probably heard of. They've had a lot of press in the cloud space from very early on. Uses both an alert-based scaling process as well as a grid process to render videos on demand to users that are submitting still photographs. And then financial services, this is a key one and probably not a surprise to anyone in this audience, processing things like back testing on option pricing when the market closes if you're a hedge fund, or just routine, pricing metrics based on algorithms that are set up within a financial services industry workload. So just a few of the use cases that we're seeing so far. So why is this? Why are they moving to the cloud, and why are they taking advantage of their resource pools that are available there? Well, there's a couple key value propositions that solve some of the fundamental challenges that you saw me talk about earlier there a few slides ago. This first is this notion of resources on demand. So this is a recurring theme that you hear about in cloud computing. This whole notion of pay-as-you-go and on-demand is a key value proposition. What that leads to is resolving these scheduling conflicts, all right? So you're not limited to this queue that's sequential where you're constantly fighting for prioritization. The second is this notion of virtually infinite resources. The scale that these providers operate at, providers like Amazon, far exceeds even the largest internal enterprise data centers. So because of that scale, you have flexibility and you have options to run workloads that simply do not exist in your internal environment. That can lead to faster processing, things of that nature. And then last but not least, you heard about fixed costs being one of the hurdles and one of the challenges. Well, the cloud is all about variable cost, pay as you go. So you can match your spend to actual work that's being done. This is kind of an evolutionary thing that's really revolutionizing how you do cost accounting internally. So be able to apply back to different business units and different users exactly what a specific workload costs them is a pretty amazing concept. So those are some of the cloud value propositions. So this on-demand, virtually infinite, pay-as-you-go. So layering in RightScale on top of that, you saw that slide that Michael took you through. RightScale is really all about orchestration and automation and administration around the underlying cloud resources provided from folks like Amazon. So specifically what we do as it relates to grid computing is we add a couple key things here. Again, not all encompassing, but just some of the key value props. First is all around pre-configuration. Right? So RightScale uses a concept of server templates. You're going to hear and see this in action when we move into the demos and introduce Dave Welch. But think of server templates as an easy way to predefine single server and multi-server clusters. So without having to go back and do that from scratch, without having to bundle machine images that are static and difficult to maintain, RightScale allows you to pre-configure, and define multiple environments within our platform as the underlying resources come and go. The second key area is around automation. Simply put, RightScale is a rules-based platform, and it's constantly monitoring, reacting to a whole host of metrics that are coming back through our monitoring daemons based on things like attributes of the queue, based on load, whatever metric it is that you want to set a RightScale action to be triggered to, RightScale can automatically take an action on the user's behalf. And that can be things like provisioning or deprovisioning resources, but it can also be things around reconfiguring your environment. So a significant reduction in the resource overhead that an IT admin or sysadmin would otherwise have to do. And then last but certainly not least is a whole host of tools around policy management, user access, controls, and cost accounting. So the ability to actually see who did what when, what is this resource, what is this environment costing me, be able to limit by project, by department, things of that nature. So all of what you'd expect out of a world-class management system that's administering a data center environment, but applied to cloud resource pools. So I wanted to talk briefly about the different components of the solution pack. This is a big part of RightScale in our product development roadmap, is bundling together different components of the platform, which is deliberately architected to be very open, into a more coherent kind of value meal, if you will, to help customers get started even quicker and help them take advantage of best practices within the cloud. So we do have a solution pack specific for grid computing. It is available today. It includes a couple key things. The first is a pre-configured framework. There's a component in there that we call a quick start macro. Dave is actually going to show you how that macro works. He's going to run it on the webinar. That will literally create on demand a grid environment. That grid environment, again, is variable. So fundamental to the cloud and RightScale, we're talking about a variable set of resources. So that can be customized to the specific architecture and software requirements of your application. Unlike a fixed environment internally. What we've created actually does complement your internal grid engines. So if you're currently using a SunGrid engine or a Cycle Computing or something of that nature, this is not a replacement. This is a way to complement that and get access to additional resource pools. We're going to talk more about how that works. It incorporates all the best practices we've learned from all of those servers that we launch and manage that you heard about initially. It is architected on Amazon's web services offerings, specifically their queuing service called SQS, Amazon's EC2, as well as their storage resource S3. And it can be configured to work across multiple resource pools. You'll hear more about this a little bit later, but this is very, very important as you're running workloads that may be using a sensitive data set, or running workloads that may be subject to different performance characteristics, or running a workload that may require a lower cost. So the ability to, through RightScale, get access to multiple resource pools is another key value prop of the solution pack. And then last but not least, we wrap this all within RightScale professional services and support. So giving you 24/7 support via phone, and also holding your hand through that initial onboarding process. So before we dive into kind of some of the architecture, I wanted to kind of capture the theme of what I was just talking about, and I can't do a better job than what Eli Lilly did themselves when they described RightScale and what they've architected on our platform as a vending machine for IT. And what that means simply is a user on his or her own fruition can go in via web interface, or this can of course be done by an IT admin. They can gain access to pre-configured environments. Those environments can be very simple or they can be very complex. So you can have a grid that's set up to run a basic process on small instances on Amazon in the public cloud, or you can have a grid that's pre-configured to take advantage of machines that are more sophisticated and more powerful set to run on the VPC and anything in between. So they can access on-demand pre-configured environments, and they can do so with all the controls and policies and procedures in place to make sure work is being done on the appropriate resource pool and that users are leveraging compliant stacks and compliant builds and are not getting themselves in trouble by changing different configuration parameters. So think of this as a vending machine for IT, RightScale kind of governing what gets placed where and who can do what. So let's jump in and talk about the architecture. So how is this grid solution pack set up? There's really three key components here. Two remain very familiar to this audience, I'm sure, which is how it interrelates with your existing grid engine. So if you're currently producing jobs, creating messages, and pulling application code, using your internal grid engine, you don't need to change that. Okay, so RightScale can, through our job coordinator plugins, take advantage of what you're already doing internally. Where RightScale picks up the pieces is in this middle section that you see here. And this is the entire orchestration across all the different components of Amazon Web Services that are necessary to instantiate this grid and then run jobs and then react to various different attributes of that job. So this includes things like creating and managing your queues, your error queues, and your results queues. This includes things like pulling your application code out of S3, reacting to things that are going on within Amazon's simple queue service, and of course, growing and shrinking and dynamically configuring your worker servers depending on what's happening. So I want to take you through the flow that you're going to see Dave actually demonstrate in the dashboard, but it's a little bit easier to capture this in slide format first. So what you're about to see is going to be a typical flow of how RightScale will take and initiate a job using the resources that Amazon Web Services provides. Run the job, and then return the results into a series of queues that are set up and managed by the RightScale Grid Solution Pack. So here we have the job coordinator role and the input file creation and message queuing. So the core steps here are first, the job producer is going to create the input files and construct the work unit. Okay. Next, you have the input files are then placed in an S3 storage bucket. And then finally, that work unit is packed into a message, and then the message is placed into that SQS queue. Okay, so these are kind of laying the groundwork of RightScale to be able to to begin work here. And so again, I wanted to point out, so RightScale can pick up this piece, but if you have an internal resource and solution that you want to continue to use, that's fine too. There's no reason you can't create these input files and work units and upload them to S3 buckets yourself, and then leverage RightScale from there. So the choice is yours. We leave that flexible to the customer. So the next phase of the process, first we have RightScale instantiating a server. So this can be a server or servers. This is very variable, and you can set this as a user depending on what you're trying to achieve. You'll see Dave do this in the demo. Next you have RightScale, the worker daemon will copy a message out of the work queue. It will unpack the message and download the respective files out of S3. Next, the application code is called, and the worker begins to do work. Output files and logs are created and placed in their appropriate directory. And finally, the results are returned back to the worker daemon, awaiting further processing. Okay, so this is about RightScale standing up, dynamically configuring instances within Amazon, and then reacting based on what's happening when work is being done and returned to the appropriate results queue. So on that note, let's move into results handling. So here, RightScale is going to first upload the output files and the logs into their respective S3 buckets. So just like we pulled things out of S3 that may have been placed there by your internal grid engine, we're returning them to respective S3 buckets for you to then pull them back internally. The next phase is temporary and input files are deleted. And then from there, the worker is going to leverage several pre-configured queues to start the results processing. So those include the results queue, those include the error queue, and then finally, the audit queue. All queue statistics are placed in that audit queue, and then completing the job process, and then removing the message from the input queue. Great, so now that we've seen this on slide flow format, I'm going to turn it over to Dave Welch. Dave Welch is one of our sales engineers here at RightScale, and he's going to take us through a couple things in the RightScale system itself. Specifically, Dave's going to show us this pre-configured quick start macro that is part of the grid solution pack. We'll talk a little bit more about the job coordinator plugins if you wanted to leverage your internal grid engine. And then dive into a bit more detail about server templates and specifically the value propositions and why you want to take this approach to achieve this graceful provisioning and deprovisioning. So with that, Dave, take us away.
All right, thanks, Josh. So first, we're going to show how you can build out that same pre-configured grid environment that Josh just walked us through using what we call a macro. So in this case, I'm going to run the RS Grid Quick Start deployment. And then I'll be presented with a list of inputs. These will define the cloud characteristics for your environment. So once I set these, I'll click Run. And as the macro executes, it's building out all the components of the grid environment from the queues to the queue-based arrays. So this allows companies, companies have the ability to provision different on-demand grid clusters depending on the inputs that are set. We'll touch on this point later in the demo and why it's important. So now that the macro finished, I'm going to jump to the deployment page to see the newly created environment.
So Dave, this macro is really creating a system, right? It's creating a predefined system, and of course you can have multiple macros if you wanted to. It's essentially creating a grid on demand that may have different characteristics or different machine sizes, overall behavioral in terms of how big the grid will grow.
Exactly. So since it's predefined, you can have multiple users spin up their own grid environment.
Okay. So multi-server, multi-tier environment, pre-configured networking, security, kind of all these different attributes that go into kind of setting up this grid are defined at the macro level. Users can go in and simply run that macro as many times as they want to launch an environment.
Exactly. And then I want to point out on the left-hand side here that once the macro finished, it also kicked off our job coordinator. So once that comes up online, it'll start submitting jobs into this grid environment.
So that's a good segue into a little bit more about the job coordinator. So if a customer wanted to use an internal service, say they're using cycle computing, and through our job coordinator plugin, they wanted jobs that are produced and messages created out of their internal grid engine to automatically kick off a process within RightScale's grid solution pack, you could do that through our job coordinator plugins.
Exactly. So you're not limited. You can extend your existing scheduler, or you can run the job producer within Amazon EC2 as well.
Got it.
All right. So RightScale takes care of all the logistics using its server template methodology, which the job coordinator is using to configure the server dynamically. So this allows you to abstract out much of the configuration information via these global input parameters.
So in this particular case, it's using this grid quick start server template, right? And that server template includes a series of inputs, as you mentioned, right? And it's that same server template that's launching every single instance to create that grid, and then dynamically configuring it through these input parameters, which are essentially environment variables that you're defining and showing the audience here.
Exactly. So when those newly configured servers boot up, they know how to deploy itself within context because it knows which input queues to use and which output queues to use.
So the alternative here is dealing with static images. And so why do you not want to go that approach?
Well, the reason why you want to abstract this information out of the image and and dynamically configure the server is so when we want multiple users to recreate these grid environments, we don't want to have to manually configure and then rebundle those images for that particular user. So by abstracting it out, we can just change a few inputs and then relaunch the servers.
And also you're defining things like, pulling your application code down, what machine characteristics, so an instance size on Amazon is all defined at a server template level. So you can actually create, using these server templates, multiple different, fundamentally different grid environments that are predefined at a server template level, and it becomes very, very easy as an administrator to deal with the ongoing maintenance of that.
And it's very repeatable as well.
Got it.
So now let's jump into one of the scripts so we can show how these inputs are used. So here's a simple bash script, and what it's defining is it's uploading the configuration information of where the queues are located, and it's passing those inputs as environment variables to the script, which in this case we call RightScript.
Great. So let's thanks, Dave. So let's go back now and look at that deployments overview page again. And I noticed there, so I saw this earlier. So you have grid app A, you have grid app B, and then you have the RightScale, the RS Grid Quick Start. So what's going on here? I mean, these are essentially 3 different grids, right?
Mm-hmm. That's right. So we provide the ability, like I said earlier when we were running a macro, to configure different grid environments based off the inputs to match user policies for the user's workload.
Okay, so I think in this particular case, one of these grids is actually taking advantage of one instance type, and another is taking advantage of another. Is that right?
That's right. So we compare the two job coordinators in this case. We can see some are on C1 mediums and using a different machine image, and the other one. Oops, let's jump back into that. And the other one's actually on a double XL, and this was predefined at the.
Looks like we're in the same one here.
Oops, sorry. Oh, here we go. So in this one's defined as an M2 extra large.
And I noticed both of these were running on Amazon's U.S. East region. This actually is a good segue. We had someone write in a question here. Does RightScale provide services for private clouds? Absolutely. So Michael mentioned 3 different enabling technologies that we support, Eucalyptus Systems, Cloud.com, and vCloud. But that's actually an important theme here, what Dave's showing you, which is what is really happening here with these deployment configurations that were created off these macros is these are fundamentally different grid environments in terms of size, behavior, machine characteristics. Dave just showed you a very simple example. One is using these M2XLs, and the other was using these medium instance types. But also you can dictate by these deployments what resource pool they run on. So in this particular case, this resource pool is Amazon's U.S. East region. But if you, for example, were dealing with a workload that was taking sensitive data, you may want to restrict that to only run on the virtual private cloud or only run on a private cloud that's behind your four walls. So you can define various different grids predefined within RightScale that are set to take advantage of different machine characteristics, have different sizes and attributes that are set to run on different resource pools. So you have a variety of different controls around all this, making it very, very easy to ensure that the appropriate workload is being run on the most suitable resource pool depending on security, performance, cost, things of that nature.
And it's also important to note out that this grid environment is adapting to the user's application. So they're not going to have to go in and tweak the grid environment to fit the workload. It'll adapt to them as it's provisioned.
That's a great point. Yep.
So now I'm going to turn it back over to Josh, who's going to go over some of the scaling options.
Great, thanks, Dave. So let's jump over here to the slides and talk a little bit about the RightScale automation. And want to touch upon some of the most common things that we see customers using within RightScale as it relates to this grid solution pack. So the first type of automation that we see is around RightScale alerts. So what RightScale alerts are is those are pegged to system-level metrics that RightScale system is monitoring. Again, every instance that's launched with the RightScale platform is under RightScale's active management, and we're streaming monitoring information back to the RightScale court systems and taking action based on metrics that you set as a user. So things like CPU utilization, I/O, requests, so on and so forth. Anything that you're monitoring can lead to an automated action within RightScale. An action within RightScale is simply something you want the platform to do. That can be provision a resource, deprovision a resource. You can actually reconfigure a single instance or an entire cluster by running runtime operational scripts. So it's all user configured, and it's all dependent upon what metric you want to peg that to. The second type of array configuration is around scheduling. This is fairly straightforward. So time of day, day of week. So a great example of this that probably everyone can appreciate is financial service companies. You know, the stock market closes at the same time for everyone. So, you know, you can, based on very predictable work that needs to be done based on a time of day and day of week, trigger this grid environment on demand, or grid environments, plural, trigger that on demand based on a schedule to instantiate and start processing work. The next category of array automation is around attributes of the queue. So you saw in that first high-level architecture slide that core to the RightScale system in their grid solution pack is leveraging Amazon's SQS, their simple queuing service. Because we're leveraging that, RightScale is monitoring and reacting to a full host of queue-based metrics. So things like, how many jobs am I waiting to process? So what's the total number of backlogged messages in the queue? That may require the system to grow or shrink. We look at aging of messages as another way to automate. So this is actually commonly used to deliver against specific SLAs. So if you want to ensure that your job gets processed in a specific amount of time, RightScale, you can peg that within RightScale and dictate how many jobs any one given instance can process and how long you want to allow something to age in the queue before you provision additional resources. And then finally, RightScale has the intelligence as a system to understand the underlying charge model of the infrastructure provider itself. So specifically with Amazon, they of course charge by the hour. So even if you've launched an instance and it's currently not processing any workloads, RightScale will keep that instance running for as long as it possibly can, but still maintain enough time to deprovision it before you get into that second hour of charging from Amazon. So it's got intelligence to optimize costs based on the underlying charge model. So let's talk about some of the key benefits around automated management. You've heard several of these themes come up in a few different areas, including the demo, but just to quickly summarize them here. First key benefit is around remediation. So again, RightScale can react to and deliver an escalation, so a RightScale action based on any of the metrics that you're monitoring. So that could be configure a new instance, deprovision a resource, bring a new instance into a cluster. Make sure you adhere to a specific SLA. So anything that you're monitoring within RightScale can drive RightScale remediation. So it's dramatically reducing the overhead of what it takes to create and manage grid environments. We also support chaining. So this is the more complex batch processing where you have the results of one grid array are leading to the inputs of another. So you can chain together multiple arrays. You have the efficient spending and the controls around that. So that's largely used by using the RightScale scheduler based on time of day and day of week. But also, again, you have access to multiple different resource pools within RightScale. So certain resource pools may have different rates. They do on Amazon, for example. Amazon's regions all are slightly different costs. And then finally, we have the ability to actually lower the overall costs. And this is done in really two ways. One way is just the better utilization of your grid environment. Okay, so you're spending very, very wisely. Okay, the second is around taking advantage of some feature extensions from Amazon itself, things like reserve instances, where you essentially can buy down the on-demand rate. And second is spot pricing, and spot pricing is more of an auction model for instances. And this allows you to, one, get a lower price, or another way to use spot pricing is to actually get a larger machine, a machine with more horsepower, if the price has fallen in that given hour to an acceptable level. So those are just some of the key benefits of the automated management that RightScale provides. So with that, I actually want to turn it back over to Dave, and Dave's going to show you some of what you just heard me talk about, the configuration parameters within your arrays, and then we'll take a look at the results. So he actually kicked off that job when he ran that that grid solution pack macro that actually automatically started processing the jobs that were in that queue. So Dave's going to take a look at the results, and we'll talk a little bit about that.
Great, thanks, Josh. So let's continue with the deployment we created in the first demo, but this time we'll focus on the queue-based array that was created. So an array is an elastic set of servers, but it's important to note that the same server template is used to launch multiple instances. And each server template also defines the cloud characteristics and inherits the inputs from the deployment level so it can be deployed within context. Next, we have the server allocation policy. So by default, we have a minimum cap. So this allows us best practices to keep a server running so it can process the result immediately. And then we have a max count capped at 10. And the max count is usually used to control cost.
So one example here, Dave, just talking about the different vending machine concept and resource pools in the context of this max count is you have this array, it looks like, set up to run on Amazon's US East region, correct?
That's right.
Yeah, so you could set up a specific limit in any given resource pool that you want that array to grow through. And then you actually could set up additional grid arrays that are set to start growing in other regions when you reach that cap. So if you want to go from private cloud to VPC, or if you wanted to go from one region to the next, you could do that.
Well, that's a great point. And your job scheduler can then determine which queue and which array to use.
So both for performance attributes, for cost attributes, for high availability. So different resource pools can be stitched together, and logic around how large you want your environment to get within any given resource pool, it can be configured within these array settings that you're showing us.
And that's another great point with the the availability zones. Not only just the different kind of regions, but also within the same region, you can specify for high availability which zone to provision a new server in. So next we have kind of the queue options here, and this determines the scaling attributes. So in this demo, we're scaling based off the queue size. For example, for every 3 items we have in the queue, we're going to go ahead and provision a new server to handle the load. Likewise, we can also use the item age. If we ever want to meet SLA requirements, so if a job has been in the queue for 5 minutes, well, let's go ahead and provision a new server because we have to meet our 10-minute SLA.
So it looks like, so in this particular array, we have 2 defaults. We have queue size, and then we have item aging. Could you also have remedial action that RightScale is taking based on load-based metrics that are coming back from your application's performance?
So that goes back, to the server template that also has the cloud characteristics. But you can also, like you said, attach alerts to that server template, so you can do other self-remediation actions such as running the script.
Got it. We actually see customers doing that. So Animoto that we mentioned earlier actually has an array that's set to adhere to an SLA, so an actual worker array that's set to adhere to an item aging. It reacts to that, but then the front end and the application servers that are processing those requests and taking the uploads of the photos and the music files is also growing and shrinking, based on certain load metrics that are set.
Yeah, so it's a great point because you can complement the two with alert-based and queue-based scaling.
And this is just something that's just not possible in an internal grid environment, right? Because your environment there is fixed, both machine characteristics and total size. So here you have multiple different grids, sometimes producing the same ultimate job. So at the end of the day, this video in the case of Animoto, that are actually, behaving differently based on metrics that you set within RightScale, potentially located in different resource pools. But RightScale is dealing with the orchestration to stitch all that together.
That's right, and you can extend that internal resource pool into the Amazon VPC.
And so we actually had a question, so this is a topical for where we are right now, which is how can I control my internal grid resources with RightScale? So there's no reason that you couldn't be viewing your internal grid as another resource pool within RightScale. Is that right?
That's correct. And
so in that case, if the grid engine you're using supports plugins or has an API, just like RightScale is instantiating servers in Amazon's VPC and Amazon's public cloud, there's no reason that could also be launched on your internal grid.
Yeah, all it would take is just to kick off the job into Amazon's environment. Okay. So now let's go check out the results of this job. So I want to point out on the left-hand side here that a lot of the RS grid workers are now operational, so they've probably processed all of our jobs. So in order to view the results, I'm going to go ahead and run the job consumer script. So it will consume the results and display it on the web page.
So this operational script that you're just running here, so describe a little bit of what you're doing here, and does this have to be done manually? Could you set this up to be done automatically?
Yeah, so typically this will be set up automatically. It'll be running indefinitely on its own server to consume the jobs in real time. To point out here what we're doing, we're running an operational script that was set on that server template. So from the RightScale dashboard, you're able to push scripts out to one or multiple servers.
So this is runtime configuration configured at a server template level that an administrator can set to do dynamically, automatically, or it can be manually run as you're doing here.
Exactly. And then under both cases, just while the job's running, I want to point out that everything's audited within our platform. So each action and who took that action is stored in the RightScale dashboard. So the job is probably finished. So let's jump back to the server and check out the results. So here's just a sample or subset of the images that we ran. And as you can see, this is just a basic image conversion tool. So for the first two, we had the job that was completed. But for the third one, so since it's for demo purposes, we actually simulated an error. So there was no image available.
So Dave, talk a little bit more about the error queue and the options there. So what does RightScale do with them, and what are your options as a user in terms of how you react to errors that are created?
So just like the job consumer, that you can consume those messages, you can consume the error queue as well to determine if you can do anything, if it was an incorrect syntax, and then re-kick the job off, or you can just flag it for later viewing. So in this case, I'm going to jump into the error queue to see what the error message was. So I'll view the top item, and this is just going to pop the message off the queue. And as I can see here, the exception was thrown. It was an incorrect job worker name. So in this case, we consume that message and then reapply with the the correct job.
And so on these error queues and the results queues, is there any reason why RightScale can't push that back into an internal grid engine environment?
So yeah, likewise with pushing it back into the public cloud, you can do the same thing and push it internally.
Got it. So very much a complement to what a lot of customers are doing today in their internal grids.
So here we just want to finish off. We're at the dashboard overview. So as you can see here, here's the RS grid deployment that was created earlier. And it's important to note out, you get actual real-time information on the run rate or what it's costing you.
Great. Now that's a good point. So just to recap here, we have Grid App A, Grid App B, so it looks like two different applications. You showed the audience earlier. Those are leveraging different machine types. We have this third grid that was created live by running that macro. All three of these are set up in this single account called Demo Production. And the beauty here is you can create isolated environments that are able to leverage multiple different grids that can be created on demand. You have real-time spend and consumption rates. So this becomes very, very important when you start looking at things like quotas and cost accounting and giving visibility into the end user of what this job is actually going to cost. And then further, you can create these various different isolated environments. So everything you see here in this drop-down menu, these are different RightScale accounts. And an account within RightScale is dictating what resource pool you actually have access to. So again, looping back to that concept of an IT vending machine, so within any given account, you have access to select resource pools. So here we have all Amazon regions. So of course, this Grid App B is only going to run on one of the Amazon regions. But if you jump over and take a look at, in this case, let's look at Studio 2, you'll notice over in Studio 2, you have a private cloud. This one happens to be based on Eucalyptus. So you have complete control of from an IT admin standpoint to determine where these grid environments get created in terms of what resource pools, how much they're costing, and then setting up various different user roles and user classes to determine who can do what, and also auditing everything they're doing.
That was a great point. Just to summarize the two demos, so what we were able to do is we were able to show dynamic orchestration of grid in the cloud, and also the multiple different grids that you can create with multiple different policies. And furthermore, you can also extend your existing job schedulers so it's all compatible. You don't have to change what you're doing currently.
Great, so let's jump over to the slides now. Thanks, Dave. Appreciate you taking us through that. So wanted to finish up here today with talking a bit about the economic benefits, and then we've actually prepared an example of the impact of doing grid computing in the cloud. So, hopefully these are not new themes at this point to everyone, but in terms of economic benefits, you're talking about OpEx versus CapEx. So the cloud is pay as you go. So there's no CapEx involved, so significant cost savings up front. You're not having to invest ahead of time to set up these grids. You're only paying for what you're using. And then finally, RightScale is delivered as a software as a service. So not only are there cost savings associated with that, but also the RightScale platform is constantly being enhanced and evolving. So every 5 to 6 weeks, RightScale is releasing a sprint, and the product is improving. So that type of dynamic configuration and evolution within the product is very, very powerful and ultimately leads to significant savings. On the agility side, this is an area of kind of a total cost of ownership analysis that is often neglected, but business agility translates to real costs. So first, you have this notion of your job is always first in line. So if you need it to run, it's never constrained by limited resources you have internally. If you need it to run, it will run. If you need it to run in a certain period of time, you can ensure that it does. That's often driven by this notion of unlimited resources, and then finally the ability to take advantage of pre-configured environments. So Dave, what he just ran, so that is the actual grid macro that's part of the solution pack. So we've taken about the vast majority of the heavy lifting off of your plate and pre-configured it so that it becomes very, very easy to consume. So in any business where time is money, so particularly in areas like biopharma, where it's all about the time it takes from drug discovery to FDA approval, if you can get your jobs done faster, all right, when it comes from the initial request for resources to actually having those resources provisioned and able to accept work, if you can reduce that time, that translates into real savings and actually real economic benefit. Wanted to quickly mention Amazon's public data sets. This may be a new concept to many of you in the audience. It's worth checking out, so go to aws.amazon.com and do a search on public data sets. What this is Amazon has actually started to host at their expense multiple different public data sets that anyone can go in and access. So things like the U.S. Census Bureau, information from the National Institute of Health. So there's an ever-growing list of public data sets that Amazon on their dime is storing and maintaining on customers' behalf. You only pay for when you go in and actually consume resources to access that data set. So this is a great new enhancement in Amazon's offering, and I encourage everyone to check it out. RightScale, of course, is indifferent to any data set, so if you're leveraging a public data set, that's great. It just means one less step that you have to do as a user. And then finally, I wanted to leave you with this cost-neutral equation, and then we'll get into the specific dollars and cents. I just find this as a really simple way to capture the power of what we're talking about with agility, which is, you have this ability in the cloud to, if you're running 10,000 jobs and you're looking, hey, do I run it internally on a fixed environment, or do I run it externally in a cloud environment? And in a fixed environment, you may only have access to 2 servers, let's say, for that particular job. Say there's other jobs going on, higher priority, et cetera, et cetera. So that job would actually take you a total processing time of 500 hours. Right? In the cloud, you can take that same 10,000 jobs and spin up 1,000 servers on demand and get that job done in an hour. Right? And the difference from a cost standpoint between doing a 2-server cloud when you're deploying through RightScale or a 1,000-server cloud is exactly nothing. There's no difference. So you're paying the exact amount to grab additional resources because the total processing time is reduced significantly, and you only pay for what you use by the hour. So it makes you very agile, and you're able to produce workloads very, very quickly. So here's the bottom line. We wanted to leave you with a study that was done by a third party called the FactPoint Group. So they did some research on behalf of RightScale and wanted to take a look at how in-house grids, factoring in some of the core components here, would compare to cloud-based grids that are managed by RightScale. And you'll notice here that the reduction in cost is quite dynamic here. So this is a significant savings. You're talking about 1/4 of the price of what it costs to set up and maintain a typical in-house grid. And this is without even capturing a lot of the business agility that we talked about earlier. So dramatic, dramatic savings. And that concludes the slides. We'll keep the audio on and keep the chat log going, and we'll keep answering some questions here. But a quick couple wrap-up items before we do. We'll leave this screen up, but we'd love to talk to you. We understand many of you are new to the cloud and new to grid computing in the cloud. So if you just have a question, want to talk about your use case, want to pick our brains, we'd love to hear from you. We understand it's a very consultative process, and we're here to help. We actually have done a grid computing white paper. It is publicly available, so it's today. You can go get it at rightscale.com/grid-solutions, so we encourage you to download it. That was prepared by our services engineering department and talks a lot about what they found from different performance and best practice scenarios in the cloud. So great content for you to take advantage of. And this webinar, as with all of our webinars, will be archived, both the audio and the video, and that's available at rightscale.com/archives. So with that, let's take a few more questions and keep the Q&A coming through the log, and we'll keep that open if need be past the hour.
All right, Josh.
So Dave, what do we got?
So if we lose connection to the grid, then will that job be stopped, or can we resume the job after we get connected to the grid? This is a great question. So if one of the servers that's processing the job was to fail for any reason, then you would not lose that job. Actually, it would be put back onto the queue, and another one of the grid servers will then grab it and process the job result, which will then be posted to the output queue. Right, well, there's another question. How can we define whether the grid begins, where the grid begins, and where it ends for our customers? Well, in this case, you can have those servers kind of waiting idle, and when jobs are starting to submit, those servers will then be provisioned, process the results, and then terminate within the hour. Since you pay for it by the hour, it'll wait around for any newly provisioned or any new jobs that are created. If there aren't any jobs in the queue, then at around the 55th minute, the servers will then deprovision.
Great. Next question we have here is around hardware requirements. So specifically, how do we know what hardware we require in order to perform our tasks? So this is an interesting one. There's a couple things to note here. First and foremost, the RightScale Grid Solution Pack includes that onboarding process with our services engineering team. So part of that process includes dealing with the RightScale experts who have done this time and time again, who will help you understand how to map your internal environment to the cloud environment. The second thing to note is what Dave showed you in the demonstration around server templates, which is Amazon is supporting, and this is a constantly growing list, multiple different instance types. Okay, these range from very, very small machines that don't have a lot of power that are actually shared, all the way up to significant machines with a lot of horsepower, big in machine memory and CPU, so on and so forth. So you can configure at a server template level what specific hardware configuration you want to take advantage of, and that can be defined and then repeated with every instance that you launch. So you're not confined to configuring each instance. You define that at server template level, and then as servers are launched, it's configuring the appropriate instance based on what you've defined. So we'll advise you, and then you can configure in the platform what's right for you.
So roughly how long does it take to spin up a new VM or instance, or say 100 new VMs? Well, as you can see in the demo, we had about 7 servers that were launched. So what we see roughly is each server takes approximately 5 to 7 minutes to be provisioned. And that depends on what you put in your server template and what you put in your image. Now, for say 100 new instances, that'll take roughly around the same time, but a little longer to make those calls on your behalf, so you can see the 100 new images up and running in about 15 to 20 minutes.
Great. So next question looks like some costs. So we have this RightScale support Amazon's reserve instances. So yes is the answer to that question. And just to elaborate for those that aren't aware what reserve instances are, Amazon's reserve instances allow you to essentially buy down the rate in a specific region within Amazon's cloud offering. So there's 2 reasons why reserve instances are important, and we see more and more customers taking advantage of this. One is it's a way to guarantee capacity in a specific location within Amazon's cloud. So if for whatever reason you want to make sure that every resource you pull is in a specific region and you want guarantees that a specific instance type is going to be available in that region, reserve instances are a great way to do that. The second key thing with reserve instances is you actually pay a lower rate. So think of it as a lease. So you can essentially buy down the rate by paying a modest amount up front, and then it still pay as you go from there. So instead of paying, in the case of a small 8.5 cents an hour, you're going to pay a rate as low as, I believe it is, 4.5 cents an hour if you're buying a 3-year reserve instance. So tying in RightScale to that equation, this is where you can really start to get creative on how to most effectively spend and consume resources. So RightScale has the intelligence to know that you have reserve instances. You can set those up actually through our platform. And you can configure RightScale to, for example, only run jobs on a certain number of instances because they're reserved in a specific region. So it's a great way to kind of combine the two to really optimize what you're doing and pay as little as possible.
I think we have time for one more question. Do you have a free site to learn the resources? So yes, we have a free developer account that you can use. You can kind of get familiar with the RightScale dashboard and the tools we provide and the server template methodology and all the other components that we went over today. So feel free to sign up and play around with it.
Okay, looks like a few more coming in. So again, we'll stay on as long as questions keep coming in. So next one is around looks like the VPC. So specifically, does SQS work in the VPC?
Yeah, so the SQS does work in the VPC. In this case, it would just be routed through your internal data center.
Right, so SQS is an Amazon global resource, just like S3. Is that right, Dave?
That's right.
Yeah, and so the VPC is a great way to do some added security around what you're doing within Amazon. So it's a dedicated VPN connection into your data center, and you're creating private subnets on Amazon's EC2 environment. The VPC is not yet available in all Amazon regions, but the regions that it is available in, there's no reason you can't take advantage of SQS within the VPC environment as well. And that actually brings up, just another reminder, RightScale is independent in terms of what resource pools you want to deploy in. So back to that vending machine concept, a recurring theme that we have here, which is if you want to deploy in US East Public, you can do that. If you want to deploy in the US East VPC, you can do that. If you want to deploy on a private cloud, you can do that. So you can create these isolated environments that can be oriented around a business unit, project, and individual, and dictate where those jobs get run. Great. Well, why don't we wrap things up here since it's a little bit past the hour. And want to remind everyone again, feel free to contact us. We'd love to hear from you. And then take advantage of that white paper. It's completely free and available today. And then this webinar, usually it takes about a business day for us to do the processing here around the webinar, but the audio and the video will be archived at rightscale.com/webinars. Thanks, everyone, and we look forward to hearing from you soon. And keep on the lookout, as Michael mentioned, there will be a subsequent webinar that we do very soon that's more oriented around HPC. So stay tuned for that. And we look forward to talking to you then.